I'm going to focus on what you're going to learn in the TinyML program. Specifically, I'm going to focus on the 3 core parts. And across all 3 parts, there are a certain set of fundamental principles we'll be going over. Now, recall that part 1 focuses on the fundamentals of TinyML, where we are focusing primarily on the language of machine learning with an interesting twist towards timing. In part 2, we're going to be talking about different applications of TinyML, like keyword spotting. That is, when you say Alexa or when you say, OK, Google. There are many other interesting applications we'll touch on. In part 3, we're going to learn how to deploy that on our tiny little microcontroller. Now, across all 3 parts, there are a set of core areas that we'll be walking through. And those are machine learning, applications, and embedded systems. We'll be touching on all 3 of them to the extent needed. But the critical thing about this program is that we'll be focusing mostly on the interactions that are going to be happening over here. For instance, you recall that we talked about the elephant edge previously. In elephant edge, what's the application? The application is taking care of or protecting these gentle giants. But now what's the ML aspect? The ML aspect is actually doing risk monitoring, activity detection, and communication monitoring based on the sensors that are going to be on the elephant. So the critical nugget, the intersection really is this, that you need to understand the fundamental needs of the application and understand where and why and how ML is going to serve that purpose. In a similar way, we're talking about TinyML applications. When we say, hey, look, we've got this interesting thing that the application can benefit from ML, well, then the question becomes, how do I actually deploy this onto this tiny microcontroller that has very limited capability in terms of computing and in terms of power consumption? And as long as, well, they're not going to last forever if you keep running them with a lot of demand on the compute. So how do you bridge these 2 worlds together? Well, to do that, you need to understand the hardware's performance constraints and power constraints. And at the same time, you need to figure out how can you make that machine learning and deploy it onto this device in a way that can run it all the time. So those interactions require to understand not only the machine learning, but also the hardware constraints, because that's the marriage that enables TinyML. Now, there's also the aspect of knowing the application needs and then intersecting that with what the hardware needs to be. So you might have an interesting application like smart glasses that we spoke about earlier. Well, what does this application really need in terms of form factor? Well, clearly they're smart glasses, so that has to be really thin. And at the same time, the application demands that you have to have real-time characteristics. For instance, if you're doing real-time speech translation, where someone is talking to you and you're listening to it, and it's translating the words, and they're going in your ears, well, you want that to happen seemingly at the same time. It cannot be like someone said something, and then 5 seconds later, it goes in your ear. Well, that's not going to help with the conversation. But all of that has to fit in the small form factor, right? And that's the intersection between the application needs and its characteristics, and the embedded system needs to be in this form factor and so forth. So you need to understand those interactions. At the end of the day, it's all about putting each and every single one of these round circles together, because these domains need to intersect. And that's when you actually enable TinyML. And that's what we're going to focus on. So how are we actually going to go about getting there? Well, first and foremost, I want to say that in this class, we're going to really focus on understanding the content, but you're also going to have to practice it. So in order to practice it, we're going to be doing a lot of hands-on learning. So while we talk about, the concepts, while we talk to you about these concepts, we have a lot of assignments where you will actually be going through programming things in TensorFlow, which is the key thing. But not only that, we'll be talking about different variants of TensorFlow. And you need to understand this because these machine learning frameworks are specialized to do different tasks on different platforms. So if you want to be able to enable TinyML, you need to be able to understand how TensorFlow needs to be adapted in order to be able to run on a tiny little device. So we'll be teaching you about TensorFlow, TensorFlow Lite, and TensorFlow Lite Micro, and then deploying it onto the device. Now, clearly, you're going to have to solve certain tasks. So you will have to do programming of that. And you'll be doing that in a web IDE or an integrated development environment. And I'll talk about Google Colab later if you're not familiar with it. And you'll be deploying this onto a physical device at the end of the course. And so you'll be first training the software on the Colab, and then finally you will move it onto the physical device. Now, this physical hardware is going to have you interface with a couple of sensors, which is very exciting because not only are you going to be just getting a small computer, you'll also be physically connecting to a different part. And it'll give you a little bit of a taste of embedded systems. All this is going to come packaged in this nice little box for you over here. And when you open this box, there are going to be a whole bunch of things that will enable you to do different TinyML applications. Let's just take a look into this small little wonder in this box. If you look at the microcontroller board, this thing is jam-packed with sensors because TinyML is all about sensors. It's all about processing the data that's coming through these sensors. So you have a color, brightness, proximity sensor. You have a digital microphone that can pick up sounds. You've got a motion, vibration, orientation sensor. You've got temperature, humidity, pressure sensors. All of these different sensors can enable a variety of different application use cases. Many of these sensors are quite critical to the kind of problems that people are trying to solve in the real world. So you have the right building blocks over here. And all of this comes with an ARM Cortex-M4 microcontroller. The microcontroller is effectively the processing engine, the heart of the system. And an ARM microcontroller is widely available in the real world. It's deployed nearly everywhere. So you will be dealing with a real microprocessor where you can say at the end of the class that I've actually programmed this microcontroller to be able to do tiny machine learning, which is very exciting. Trust me on this. And so you'll not only be dealing with the components on board, but you'll be also packaging all that excitement into interesting applications. For instance, we'll be looking at something very, very similar to saying, okay, Google, we'll train on a small little model that will respond to your words. And we'll use the vision sensor in order to be able to do interesting things from the camera input that's coming in, like detecting people and detecting you. And we'll use the accelerometer data and the gyroscope data in order to respond to things when your hand is moving and making gestures, for instance. And we'll program some of these assignments in the software world. Then in part 3, we'll actually take those applications and learn how to deploy them. Now, because it's an embedded system, you need to learn what deployment actually means. It's not as straightforward, but that's the beauty about it. Once you learn the skill, you will have mastered a very, very powerful skill. So with all that said, I promise you this is going to be very exciting. So stick with me and I'll see you in the next video.